Okay, hi guys. Good day. Okay, so welcome to your subject, differential calculus or Calc 1. Okay, so in this subject we will be using the platform Canvas instructor. Okay, so we will be using the platform Canvas instructor, and you have here your page. Okay, so if you will click these buttons here, if you want to know about your instructor, just click this instructor's profile. And if you want to, of course, you need to know also, of course, your syllabus. So click the syllabus button, and then modules. This is now where we will be tracking where we are on our subject. Okay, and this is where you will be downloading your handouts that you will be using. Okay, and of course, students orientation if you have any other concerns. Okay, so this is the page. This will be the front page if you will open your Canvas portal in this subject. Okay, so you can see here your course overview, but the important here is for me to introduce you to the subject. Okay, so it's up to you. You can open the instructor's profile and the learning modules once we will now start. But first, it is important that we should know our subject. That's why, okay, I will be discussing your course syllabus. Okay, so this is our course syllabus for differential calculus. This subject is 4 units, and this is pure lecture. Okay, this is 4 units. Is there a prerequisite of this? No, there is no prerequisite. If you say prerequisite, is there a subject that you need to finish before taking this up? Because actually, technically, if you will try to enroll directly in engineering course, and you came from STEM strand of your senior high school, then there is no problem. You can just directly go to start with your calculus. This is your very first mathematics if you came from STEM strand. But if not, then we are offering the bridging mathematics. That is only for those who are coming from different strand. Okay, so we are offering that bridging math. So for those who did not came from STEM, then they should have this prerequisite, which is the bridging mathematics. But if not, if you are from STEM or if you already finished that bridging mathematics, then directly you can enroll your Calc 1 or differential calculus. Okay, so in this subject, okay, what is the description of this? Okay, so differential calculus is an introductory course covering the core concepts of limit, continuity, and differentiability of functions involving one or more variables. This also includes the application of differential calculations in solving problems on optimization, rate of change, related rates, tangent and normal lines, and approximations, and so with partial differentiation and transcendental curve tracing. Okay, so it seems like this is complicated for us to understand, but once we will try to break that down into its course content later on, you will understand what will be happening, what we will be doing in this subject. Okay, so but before going to that course content, what is the learning outcomes? Okay, by the way, what is this course learning outcomes? This is actually just like the criteria or this is our basis for us to give you grades if you will pass or if you will fail. Or I mean, if you will proceed now to your next subject, which is your Calc 2 or that is integral calculus, or you will still retain or you will repeat the subject calculus, differential calculus. Okay, so first of all, you need to know, okay, you need to, okay, at the end of this course, the student shall be able to acquire a working knowledge of basic concepts of function and limits. Okay, you should know what is function and limits, and you know how to manipulate functions and limits. Okay, we will be discussing that one. Differentiate and sketch algebraic and transcendental function with this. So you are going to draw equations or functions. It could be algebraic or transcendental. If you say algebraic, that is purely equations of algebra. Transcendental, that includes your logarithmic, exponential, and trigonometric. and other types of functions. You are going to sketch that one using calculus. Okay, because before, if you had your analytic geometry, you are already introduced on how to draw. If you say sketch, you are going to draw your equations, isn't it? But in the approach in that analytic geometry is by maybe investigating the parameters of the equations, or by merely getting points from equation, plotting this one, and tracing the curve. But in calculus, we will be applying this differential calculus to draw, okay? To draw your functions or your curves. And then third is that you should be able to apply the concept of differentiation, okay? Because if you will go back on these first two, these are actually all purely concepts. If you say concepts, these are just mathematics procedures and then concepts. But where the question there is, where are you going to make use of this? Okay, because you are engineering student, no, you are not a mathematics major. So that all you need to do is understand the mathematics side. You need to know how to apply that one. So that is the important here. Okay, your course learning outcome number 3. You need to know how to apply the concepts of this differentiation or differential calculus on actual problem solving. Okay, and this could be involving optimization, okay, related rates, and approximation. Okay, we will be discussing those ones. Actual problems that is involving your optimization, related rates, and approximation. You might not yet understand these terms, but as we go on, you will now know what are these. Okay, so for is of course you need also to know, or you need to comprehend the concept of curvature and determine the limits of indeterminate forms. Okay, what are these? That will be the last topics on the later part. Okay, so that is the important. Once I will see that you are now be able to show all of these 4 course learning outcomes, then you are ready to move to your next subject. But if not, then I think you need to maybe repeat again up to the time you will be able to perform this 4 course learning outcome in this subject. Okay, and in order for us to attain these 4 course learning outcomes, okay, we will be of course understanding and learning topics for us to attain that outcome. Okay, so here are your course content. This is now our topics for us to attain that course learning outcomes or your desired outcomes. Okay, so we have here your module 1 introduction part, wherein we will be of course reviewing on functions. If you say review on functions, since you already have that one in your basic algebras before, and then basic trigonometries in your high school, whether you came from STEM or your basic 4 years in high school, you still discuss there your algebra and trigo, your basic mathematics. Okay, so we will just be starting to recall first these functions. And then we will go to limits. Okay, we will now understand what is limits. Actually, these limits is where differential calculus started. Okay, it is where it is derived, your formulas in your differential calculus. So we will try to understand what is limits. So these are the subtopics. Okay, we will try to discuss all of these. And then after that, continuity and asymptotes. Okay, these are dealing with the graphs or a sketch of our equations. Okay, we will understand what are these. Derivative of a function. Okay, now using these limits here, we will try now to start understanding what is your differential calculus, or we call that one the derivative. Okay, derivative of a function. And then of course, what is the significance? What in actual scenario or in actual problems, what does this derivative signify? Okay, what is the meaning of that on actual problems? So that is your introduction. Now once we are ready, after that we are done with that introduction, we will now proceed to your module 2. We will now start with your formulas or properties of differentiation. Okay, so we will now be focusing on calculus or differential calculus. So we will be discussing there your basic formulas, these are other formulas, okay, or other rules. So these are all the concepts of your differentiation. We will be discussing all of this, and then after that we will be applying that one in a certain types of application or certain applications. So if you'll try to look at this, okay, we will now focus on differential calculus. We will try to understand the concepts and formulas of this, how to evaluate the derivative, okay, or the differential of a function. And then since we already know the concept, if we will know that we are now done with the concept of that, then we will try to apply that one on the actual problem solvings. Okay, so these are now the applications. These are the topics. Okay. So what are the certain topics? This is the important part, okay? So tangent and normal lines, okay? We are referring here to a tangent and normal lines, okay? To a curve. So we will, that is on this related to your analytic geometry. Increasing and decreasing function, the same geometry. Maximum and minimum values of function, the same on the geometry. But, okay, here's now, and of course, significance of second derivative. Maxima and minima, that is now the actual problem solvings. Okay, you have there, just like in algebra, you have a problem solving, worded problem solving. Then what you're going to do, create your equation, make use of differential calculus concept, play with your equation to answer the problem on the worded problem. Okay, so whatever is asked on that worded problem, as long as your calculus is applicable, we will now be solving that problem. Okay, so maxima minima, one is the most important or the most common application is your maxima minima. Okay, what do we mean by that? Okay, we are talking here of a maximum and minimum. Okay, so I will be introducing you that one. If we will go to, okay, so let me give you an example. Okay, okay, so let's say you have here a given budget. Let's say you have there a given budget and you want to budget that one. If you are the one who owns the budget or the money, let's say money, okay, what you want is of course to maximize the use of that money or the budget. So that is maxima. Okay, maximum value. We are trying to maximize. Okay, so that could be an example scenario. If you say minima, that is the minimum. Let's say you have there, you want to construct. Let's say you want to construct something. Let's say you want to make a cabinet. Okay, let's say you want to make a cabinet and you want to make use of the least amount of material to construct that cabinet. And that cabinet has a certain characteristics that you need to what to call this one, satisfy. Let's say it should be able to contain this amount. But of course, there are many ways for you to create a cabinet. And you will try making use of calculus. We will try to apply the concept of calculus to find the shape of the cabinet that will require us to use the least amount or the minimum amount of material. Okay, so that is another scenario when it comes to this minima. So if we will try to go on, as we will try to go there, you can see in the examples what are these maxima and minima. Okay, related rates. This is actually related to your physics subject. That's why if you will finish this calc 1, that's the time that you will now enroll your physics 1. Because in physics, okay, you had also your physics, your basic physics in your high school before. If we say physics, we are now investigating movements, let's say speed, acceleration, distances. Okay, we can now make use of calculus to deal with these topics: speed, acceleration, and distances. And then rectilinear motion, the same, that is on physics, on the motion of speed and so on and so forth. Okay, so these are now the applications. Application of what? Of what we will be discussing, the concept that we will be discussing here on top. Now, okay, by the way, before we will proceed to the other types of function, if we say function, types of equations, okay, we will first focus on the simple one, which is the algebraic. Okay, once we understand how to manipulate or how to play around with this algebraic equation or algebra equations, that's the time we will now proceed to your other types of equations, just like trigo equations. If we say trigonometric equations, there is now the incorporation of sine, cosine, tangent, isn't it? That is your trigo functions. And then of course logarithmic functions. In your equations you have now ln or log. exponential, you have the exponents. Okay, and these are the types of your transcendental. So once we are now able to understand how to apply this calculus in this algebraic equation, that will be almost the same as your other types. There will just be a slight difference, but the topics that, or the concept that we will be discussing on the algebra, will be still used on these other types of function. Okay, so let's say once we are done understanding how to apply your differentiation on algebraic function, and then we will try to apply that one on a certain applications, then we will proceed on the other types. And now we will be going to trigonometric, inverse trigonometric, logarithmic function, exponential functions. And then of course, once we already know how to deal with these types of function, the same, we will go back to the same applications, we will try to apply that one. Okay, maxima, minima, and related rates again. Okay, so you have here your module 4. Okay, L'Hopital's rule. This is actually indeterminate forms, that is actually continuation of your limits. Okay, and then differential. Okay, another approach on how to deal with your derivatives or your differential equations. And then parametric functions. Okay, this will, if we can reach this part, the partial differentiation, this is what you will be needing if you will go on your higher mathematics. Okay, so that's it. That is for the topics. Okay, again, if you will now try to understand all of this, that will lead us for you to have your out, or for us to see the outcome in you. For in this is, these are the four outcomes that we are expecting you to be able to show us once you will finish these topics. Okay, so that is how we will know, how we will determine if you are ready to go or to proceed to your next higher subject, or uh, repeat the same subject. Okay, so that's it. You have here your references. Okay, this is our textbook, by Love in Clyde, Love and Clyde and Drainville. Okay, this differential and integral calculus. And then you have here other references. Actually, this is what I've been using, because this is at least easy to understand, since this is a Filipino author, Feliciano and Oy, the same differential and integral calculus. But of course, and so on and so forth, you have there a lot. But if you only have that one, okay, I do not require this. Of course, I will not require that one, because we are not on the face to face. So we will depend on online resources. So you can also make use of your websites. Okay, these are actually a practice websites, your matalino.com or mathsfan, and then ematzone. Okay, you can just click these websites, you can now be directed to that website. But actually, since I will be okay, if you will try to look at my announcement, I am actually, there are two types of discussion: synchronous or asynchronous. If we say synchronous, there will be a time that I will be opening a portal for us to have a discussion live. Okay, real-time discussion. So we'll be having question and answers. So, or we will be having topics. I will be discussing and you will be listening, and then you will be asking questions if you have questions. And we have what we call as the asynchronous. Okay, let's say we do not have much time, or let's say we are trying to, not everyone could be able to attend this synchronous discussion, then I will always be recording a video of this. Okay, at the same time, I will be uploading your module. That is your basic, that is your main resource, your modules. Okay, that is your main resource, your modules. It is a written discussion. Okay, and I will just be recording for additional, of course, so that we will just like be discussing face to face. Okay, it is a, what do we call this one, additional reference, your video. But of course the video is still what am I discussing on the video is the same module that I will be uploading, your reference module. Okay, so everything will still be on your module. Okay, so that's it. But okay, since others are actually the first time to be here on the to enroll in this university, I need to discuss the grading system. Okay, it's okay with those who are done already with their bridging math, who enrolled their bridging math before they went to Calc 1. But those who directly came from STEM, then maybe you do not have any idea on your grading system, how we will compute your grades. Okay, so that you can always react, or you can always say if there is a correction on how we give you grades. Okay, so let me just okay, this is a worded the same, but this is in tabulation form. Okay, so this is the computation of your scores. So okay, this is your computation of your scores. By the way, for this subject, for our engineering subjects, okay, for our engineering subjects, if you say engineering subjects, that could be your major or your mathematics. But in your minor, that depends on the system, or on the way of the college that are offering that minors to compute your grade. But for us, for your engineering subjects and mathematics subjects, our passing score is 60. So what does that mean? That is what you should target in every activity. Let's say you have an activity which is all over 10, you need to get at least 6 for you to pass. Okay? For you to pass the required passing score on that subject. Let's say 100, you should have 60. Okay, so always 60%. Let's say, okay, in the previous activities you have there, you only be able to gather there less than 60%, then that will now give you an idea that for the next or succeeding activities, you need to get a higher than 60 for you to equal that less than before, or that discrepancy before. You need to fill that discrepancy before, because again, if you will try to compute that one, convert that one into a single grade, because that single grade on your finals will determine if you will pass or fail. Okay, and if you will try to combine everything, that should be 60% of every activity, or the average is 60%. Okay, but our grades is not in terms of this one. Okay, in terms of score, the passing is 60, but what will reflect in your grade is 75, because the passing grade in this university is 75. Okay, 75 and above, that is passing. If you are less than 75, it means you need to repeat the subject. Okay, so when do we have that 75 grade is you should have again an average of 60, at least average of 60. Okay, once you will compute everything, the average of all your activities, and that will be less than 60, then you will expect a grade which is less than 75, and that is failing. Okay, so now how are we going to compute? By the way, before in our university we have 3 grading system. Your prelims, okay, so we'll be having exam on prelims and you will be having a grade, midterms and you will be having a grade, and then the last exam, and then you will be having a grade, that is finals, 3. But now we reduced it into 2, only midterms and finals, 2 division of grading. Okay, so the question is how we will give you your grade on midterms and how we will compute your grade on finals. Okay, so this is in your tabulation. So raw midterm score, it means if you say raw midterm score, that is your performance on midterms only. Okay, so that will be coming from half or 50% of your class standing. If you say class standing, that includes your this one, okay, that includes your quiz, seat work, and assignments. And if we will be having there, of course, oral participation, that will be included, okay, in your class standing. And then the half of that of your score will be coming from your midterm exam. Okay, since we are talking here of your performance in your midterms. Okay, again, there is no prelim already, only midterms and finals. Okay, so again, how will I compute your score on the midterms? That is 50% or half will be coming from your quiz, seat work, assignment, and then oral participation. Combine all of these, get the half of that. And the half, we will be getting that one from your exam only. So as you can see, the exam, of course, will always be the one that has the higher percentage. Okay, your class standing, a combination of other activities, but for the remaining half, that is just your exam. So you need to do good in your exam. Okay, so if I will combine this half of class standing and half of midterm exam for you to have a passing score of 75 and above, you should have incurred at least 60% of the total of that activities. Okay, so how about if we will proceed to your finals the same? But of course, we will just be focusing on your activities on finals. So the same computation, one half from your class standing, one half from your final exam. Okay, combine all of these. So you will be having a grade on midterms, but the question is the grade on your final. How will we compute the grade on final? Okay, this is a raw final score. If you say raw final, that is just the performance in your finals. So you will be having a performance on midterms, performance in finals. Now, okay, you will be having two different grades, but we will need to combine this one into a single grade. Okay, combine this one into a single grade. So how will we combine that one? Just get the half of midterm, get the half of finals, combine that one. That should now be less, at least 60%. Again, for you to have is 75, because that is now your final grade. That will now be determining if you will pass or if you will fail. Okay, so half or 50% is coming from your raw midterm score or RMS, and then the half is your raw final score. So it is a half. Your performance on midterms and then your performance on finals, they are on the same weight, half. Combine all of these, that will determine if you will pass or if you will fail. Okay, so let's say you are not able to satisfy the minimum 60% in your midterms. Then you should now try to do your best in your final for you to fill that discrepancy in your midterms. So that if you will get the one half and one half of that and then combine, you will end up with at least 60% so that you will pass. Okay, so that is how we compute your grades. Now again, let me just explain a while ago that your score is not your grade. What do you mean by that? Again, as I'm explaining a while ago, your 60% is equivalent to 75 in your grade. Okay, so your score is not your grade. Your score is transmuted into a grade. Okay, but actually what matters here is your score, because if you will not bet that 60%, you will not pass. Okay, grade is just a number corresponding to a certain score. It is just transmuted. So it says there that scores are transmuted to an equivalent grade. For a score of at least 60, this is what I'm saying again, would be the minimum passing grade of 75, because our passing grade is 75 and above. Okay, so that's it. That is for our subject. Okay, so now again, this is your introduction. So on the next video or on the next discussion that we'll be having, we will now be starting on your module 1 introduction. We will be starting on these topics. So since again your canvas is already ready, if your canvas is already ready, this is now where we will be focusing, because this is our official platform. Everything is there. Your activities, your modules, your discussions. Okay, we just created Facebook groups for if your canvas is not yet ready. Okay, so that will not just be wasting time. That's why while they are finalizing your canvas, we are using your Facebook. But now, okay, it is already there, so we will make use of that. Okay, so again, okay, let me just discuss the flow. So what am I going to do is that, okay, so let's say I prepared your module. Okay, I already have uploaded your module, and of course if this is not your schedule, we will not be having a synchronous or live discussion. So I will be recording. If I have time to record, I will be recording the video of the discussion. I will be uploading that one. Okay, so do not just expect for you to check your account, your Canvas account or your Canvas subject only in your schedule, because this is again a blended learning. So we are not just following your schedule. Okay, we are just only making use of your schedule for scheduled quizzes, scheduled exam, and your of course synchronous. If we will be having a live meeting, that is what we will be following. But of course, this will always be open. So anytime I can upload your module, anytime I can upload your recorded video. So once it is there, try to download and watch, or and try to understand your modules. Okay, do not wait for me to be saying, okay, download and watch, download and understand. No. Okay, once it is there, then download that one right away, or if you do not want to download, then watch that one right away. Okay, so that is how we will be doing. Okay, so let's say before the meeting, let's say I will be uploading there your module, and then if I have a recorded video of that, then you will be trying to open and understand that one. And then for this meeting already, if we will now be reaching our schedule, maybe I will be opening there, or I will be setting there an online discussion for our question and answer. So if you have a question and you are done and trying to understand this one, and you have a question, you can just comment that one right away below the post. Okay, the video, or if that is the module, you can comment right away. Or we have here the chat. Okay, we have here a chat in your, we have a chat, uh, we have here a chat in your, how to call this one, you have here a chat in your canvas, so you can make use of that. Okay, but you need to be specific, of course, about your questions. So if I can answer that one by simply commenting or replying on your chat, then that's good. But if you cannot just answer that one by merely words, okay, or chat, then I need to answer that one in our next live meeting, so that we will be using my blackboard. Let's say we need to draw, we need to be doing the mathematical procedure there, then I have here my blackboard for us to do that one or answer that question. Okay, so that is the flow of our discussion. Okay, don't worry if you have their assignments. So you should open always the notification of your canvas. Please do not decline the notification, because the notification will help you to notify if you have an activity, announcement, and so on and so forth. Okay, so of course that will always notify if I will be giving you an assignment or I will be announcing that one. But again, it will always notify. Let's say I will be giving you a quiz next meeting. It's either I will announce it right now, or that will be a surprise. So you need to review. So you need just like a face-to-face classroom. It's either announced quiz or surprise quiz. So once your materials are there, try to work on that already. Okay. So let's say, of course, your exams, that is always scheduled. So you will already know the schedule before we will having the exam, and same as the other quiz. But some quiz will be surprise for you to, of course, try to drive yourself to review. Okay, even without my instruction. Okay, so again, this is engineering. By the way, this is an engineering course, so you will not expect that you will just be sitting there. Okay, you need to do your best. This is an engineering course. Okay, so maybe that is only for my introduction, and the rest of the discussion will be on the other synchronous meeting or asynchronous meetings. Okay, so thank you. If you have question, comment below. If not, again, thank you very much for watching.